All right, so let's review for this test. I do have a couple quizzes right here. We'll get to that in a minute. Since we didn't take a quiz on 6.5, I want to go over 6.5 first. Okay, so what we're going to do is just go over that homework. You could ask anything from the part A, from 1 to whatever, but 18 to 25 is probably the part that's most difficult. Let me just use this, slide this down. All right, now I got a good clean slate. Let's get me my writing thing here. We'll go. Would you say 24, right? And 25? I don't know if I want to spend time on 25 because it's not going to be on the test. Is that all right? But if we have some time at the end, remind me and we'll go over it. That's the only reason. Not trying to put you off or anything. Let's see what 24 looks like. So let's draw the diagonals first. It's easier to draw a kite when you draw the diagonals. So that looks something like that. Then we connect here and here, down here and here. Yeah, it looks pretty close to what it looks like in the book, doesn't it? They tell you this little part is 9. They tell you this little part is 5. They tell you it's a kite, and they tell you this. Let's put some letters in here. P, Q, R, and S. So I believe you see something similar to this on the test, all right? So it's a good one to pay attention to. And T is in the middle. All right, so you want to find all these missing sides, and it says that PR is 24 as well. PR is 24. And they tell you these two right here. So QT is 9 and ST is 5. PR is 24. Let's talk about that PR first. Remember that this and this are equal if it's a kite, and these two are equal if it's a kite. What do I know about this thing right here? This is called our crossbar. Do you remember that? What do I know about that? This is the axis of symmetry. What does it do to that crossbar? It bisects it, that's right. So if PR is 24, so from here all the way to there is 24, what is it from P to T? It's 12, good. So that's 12. And what is it from R to T? That's 12 as well. So that's the first thing that I would do, all right? And then they're asking you to find a bunch of line segments. They're asking you to find PT. This might be like all of them, but I'll write them down anyway. QR and RS. All right, let's find PT first. Where's PT? Oh, we just found it, didn't we? All right. So, and I knew they were going to use that, so that's why I split them up. Excuse me. All right, so yeah, that was simple. So that was 12. What about QR? QR. This one. Oh, okay, I see what they did here. Now, I won't put this on the quiz or on the test, all right, but I'll show you how to do it, but it won't be on the test, all right? So we'll do that in a second. What about RS? Same thing with RS, okay? You're going to have to know something. I don't think we've done this in here. Have you done a Pythagorean theorem before? I can't remember. I think it's the next chapter. I think the next chapter we're going to do Pythagorean theorem, which is kind of weird. It's weird that they would put this on this one because it's using something that they teach in the next lesson, and they haven't taught it yet. So it's kind of weird that they would do this. But I'll show it to you really quick, all right, because I don't want to spend a lot of time on this because this is not, everybody hear me? This thing I'm going to do right now is not on the test. This could be, all right, that was easy, all right, but this one, not so much. So what do I have? I got a right triangle. Everybody see, you know why it's a right triangle? Because on a kite, how do these two things intersect? At a right angle. So this is a right triangle, all right? This little bit right here is 9. This little bit right here is 12. There's actually a kind of an easy way to do it, but you're going to learn this in the next chapter, okay? You could do this in your head. You literally could. But I'm just going to show you how some people would do it. Did you learn this in Algebra 1 at all? A squared plus B squared equals what? C squared. Yeah, you did that in Algebra 1, didn't you? All right, good. So let's use it. So the A and the B are the two legs. The C is always the hypotenuse. All right, so let's do it. 9 squared. So I go 9 squared plus B squared, which is 12. And that equals C squared, because we don't know that. That's what we're trying to find, isn't it? We're trying to find QR. So that little C is our QR. Let's do this. What's 9 squared? 9 times 9, 81. What's 12 squared? 144. And that equals C squared. Let's do this. What's 140? Let's just do it over here. 144 and 81. That's a 5. That's what? 22. 225. 225 equals C squared. I don't know if you remember this, but in order to get rid of a square, you do the opposite. What do you think the opposite of squaring something is? No, it's not divide. It's take the, what's that thing? It's a square root. Very good. I heard somebody say it's a square root. What does that mean? Like the square root of 9. What if I ask you the square root of 9? What's that? It's 3, because what number times itself is 9? Okay? What's the square root of 25? 5, because 5 times 5, right? 5 times itself, 5 times 5, is 25. Now, this is not one that you probably can just do in your head. You could use a calculator, but I believe it's 15. I know it's 15, okay? And that is C. So C is equal to 15. That's equal to 15. So what's QR? That's also 15, okay? So that's one way to do it. There's another way. I'm not going to go through the other way, the way that you could do it in your head. We'll wait till the next chapter, okay? It's called a Pythagorean triple. In case you're interested, we're going to do that in chapter 7. All right, let's do this one. This is another one. This is another Pythagorean triple. I can just do this in my head. If I know this is 5 and this is 12, I know right off the top of my head what this side's going to be. All right, but let's do the work. All right, let's do Pythagorean theorem again. Again, is this going to be on the test? No, it's not. All right, but I'm just showing you just for fun. All right, so what do we got? 5 squared plus 12 squared equals, let's call it something else since that was C. We'll call it D squared. Is that all right? Just use a different letter, that's all. All right, so what's that? 5 squared, 25. 12 squared, we already did it. It's 144, and that's equal to D squared. 144 and 25, I can do that one in my head. That's 169, right? Equals D squared. What do we do to get rid of a square root? I'm sorry, I gave it away. What do we do to get rid of a square? We take the square root, and if you wanted to put that in your calculator, you could, but I know that it's 13. So this is 13, all right? And that's SRRS, that's 13. And QR was 15. There you go. There's your answers for that. I will not put the stuff with Pythagorean theorem on there, okay? They haven't even taught it yet. But it is definitely something that you learn in Algebra 1. Okay, most Algebra 1 classes would learn Pythagorean theorem. All right. Again, in the last class, I went over number 18 on the homework, and I went over number 20. And yeah, I think that's all I did. All right, so if you want to look at those, you can do that. All right, so now what I'm going to do is go up. Actually, here's what I'm going to do. I'm not going to go up to the quizzes just yet. I'm going to go question by question on the last 5 problems, all right? Actually, it's 6 problems, last 6 problems, starting at 15. So 15 and 16, these are on the test, all right? 15 and 16 from the test. I'm going to use different numbers. I'm not going to use the same exact numbers. In fact, on some of these, like on 15 and 16, I'm not even going to actually do all the math. But I will set it up for you. You get something that looks like this. And here's what they do. They tell you all 4 angles. They kind of tell you in terms of x, all right? You understand what I mean when I say in terms of x? They don't say that this angle is 30 degrees. They're going to say it's like 5x plus 1 degrees. Does that make sense? Anybody here? All right. So they're going to do that with all 4 of these angles. There's going to be an x in all 4 of these angles. Everybody got that? You can find a problem. You can probably find a problem on that homework. that does this. So this is going to be like 5x plus 1. This is going to be like 3x minus 2, whatever. Okay, I'm just making those up. So what do I do, though? What do I do with all 4 of these angles? Like, none of these angles are necessarily equal to each other, but they do something. What do all 4 of these angles do? That's right. You add them up, okay? So you take that first angle, you add it to the second angle, add it to the third, add it to the fourth, and what do they all add up to be? 360 degrees. Common mistake is you're so used to adding stuff up and setting them equal to 180. Do you do that here? Is it 180? Why is it not 180? Because this is not a what? It's not a triangle. That's right. It's a 4-sided figure. It's a quadrilateral. All 4 angles add up to 360, not 180. So whatever this is, whatever this, and this, you add them all up, simplify it, right? Add your like terms, get x by itself, set it equal to 360, and you should be good. All right? So look for something like that. I think we went over something like that in the last class. I think we did a homework that was similar to that. So go back and watch that if you want to get a little bit more specific. Again, I'm not giving you the exact problems that are going to be on the test, but they're kind of like that. So I asked for 2 different angles. I might ask for this angle and this angle or something like that, okay? Make sense? So that's why it's 15 and 16. All right. 17, that's a good one to do. Haven't really talked about this one yet today. Again, it's a trapezoid, but it's a trapezoid with something in the trapezoid. And you might be able to guess what that is. So watch this. What if I wanted to find the midpoint of this side right there? And let's find the midpoint of this side right here. And what if I want to connect them? It's called the midsegment. Very good. Didn't even have to ask. All right. If that's the midpoint, then this little segment are equal. This one right here and this one right here are equal. And they tell you that those are parallel. By telling you that those are parallel, that means this is a trapezoid. Everybody got it? Is it necessarily an isosceles trapezoid? No, because this side is not equal to this side. Okay, but it is a trapezoid. The midpoint is the key to this. All right, let's just call it, again, make it super easy, A, B, C, D. Call this MN. That's kind of what they like calling the midsegment. Remember what's true about the midsegment? Well, it's parallel to the other 2 sides, so that's kind of important. But really, for this problem on the test, here's what we care about. The midsegment is equal to the 2 bases added up. What's this base right here? AB. And you add it up to this base. What's that base? DC. And then what do you do to those? Divide them by 2. So this is the key right here. That's your geometry. Okay, that's what you need to know. The rest is just plugging numbers in and then solving for whatever you want to solve for. We did something like this in the last class as well, if you want to look at that. I forget what numbers I used. Let's say, I think I used a 10, and I think I used a 3 in the last class. Okay? And then I want you to find, let's say I want you to find DC. All right, this bottom one right here. Let's just use one letter. Are you okay if I just put an X there, just to make it easy, instead of calling it DC? Now, there's a couple ways to do this. I'm going to show you the easiest way to do it. Everybody likes the easiest way, right? All right, so now, this won't always necessarily work. Like if this was a 3x plus 1 and this was a 10x plus 7 or something like that, you wouldn't be able to do what I'm going to do right now. But if they are actual regular numbers and don't have x's in them at all, you could do this. How far is it to get from 3 to 10? It's 7. So guess what? Remember, this is the midsegment. It's right in between. So how far would it be to get from this 10 to this number right here? It would be 7 as well. Everybody see that? So from 3 to 10 is 7. From 10 to what? 17. You see that? Because I started at 10. How far do I go down? I go down 7. 10 plus 7 is 17. And that would work. So find DC, that would be 17. That's the easiest way to do it. And you could do that on this quiz or test. I keep saying quiz all the time. On this test, that's what you could do. Here's another way you could do it with this little formula. Let's plug in numbers to the formula. So do I know MN? Again, let's pretend I don't know any of this stuff. And let's say I don't know any of this stuff. Okay? Here's another way to do it. Do I know MN? Yeah, it's 10. So I put a 10 in for MN equals, put that over 2. AB, do I know AB? Sure, I know it's 3 plus DC. Do I know DC? Nope. What do I call it just to make my math a little easier? Just call it X. And now what I can do is I can solve for X here. Everybody see what I did? I used my little formula, plugged in the stuff that they told me, and now I can do it. Do you remember, I think it was Friday, we talked about how to get rid of that 2. How do I get rid of that 2 if it's being divided? Multiply, right. So I multiply both sides by 2, multiply this side by 2. The 2's cancel. What do I get? 2 times 10? 20 equals 3 plus X. Let's get X by itself. One step and you're done. How do I get rid of that 3 if it's being added? Minus 3. So X is 17, just like we said it was. Okay? This is kind of algebraic way to do it. Doing it what we did, the way we did it earlier was a little bit of a shortcut, and that works for this problem. But again, if these were in terms of x's, probably would not be the best way to do it. This would be the best way to do it. But on the test, I do give you regular numbers. It's not going to be 3 and 10, I'll tell you right now. All right, but the process is the same. We good? All right, that was 17 on the test. 18 and 19 all deal with the same picture. So this is numbers 18 and 19 on the test. Let me draw, this is a kite this time. So I'm going to draw the diagonals. It just makes it a little easier to draw the kite if I got the diagonals first. So I'm going to connect to here. See, this way I know that I get a nice kite with those two sides equal and all that good stuff. But on this particular problem, they don't give you the diagonals. They just give you the kite. All right, and they're going to tell you some things. If it's a kite, you know that this one and this one are equal, and you know that this one and this one are equal. But they give you some angles, all right? I don't know, let's say this looks a little more than 90. I don't know, let's just make it easy. Say it's 100 degrees. And let's say this one is like, I don't know, 120 degrees. All right, so this is what they're going to give you on the test. The numbers are going to be different, I promise. They're not going to be the same numbers, but it's going to look just like this, except that's not going to be 100, and that's not going to be 120. It's going to be some other numbers, okay? And what you want to do, call this A, B, C, D. What you want to do is find angle A and D. There's one that's super easy to find without doing any math at all. Which one is that? It's angle A, that's right. Okay, these two angles right here, see those two? They're equal to each other. How did I know that they were the equal ones? Excuse me. Because this angle is in between these two unequal sides. That's the angles that are equal. Everybody hear me on this? These two angles are equal to each other because they're between the two unequal sides. So look at this angle and this angle right here, B and D. Are they equal to each other? No, because they're between the two equal sides. Okay? So they are not equal. Kind of goes backwards, doesn't it? Which you think it would. All right? So the angle between the two equal sides are not equal. The angles between the two unequal sides are equal. Okay? So what's angle A without doing any math? 100 degrees. So let's write it in. 100 degrees. Now, how in the world do we find angle D. I got to do a little math with this one. I can't just look at it. We've kind of done this already a little bit. We talked about it. This is quadrilateral, right? So you add them all up and set them equal to 360 because it's a quadrilateral. Everybody with me on that? Should be pretty easy to add up. Let's just show it. 100 plus 100 plus 120, and plus angle D, we'll just call it D, equals what? 360. Why 360? Because it's a four-sided figure. It's not 180, all right, because it's not a triangle. Everybody good? All right, let's keep going. Let's do this. Add them all up. 100 and 100 is 200. 200 plus 120 is 320 plus D equals 360. Subtract 320 from both sides. That's easy. We can do all this in our head. So D equals 40 degrees. And there you go. You got all your angles now. Again, the numbers are going to be different on the test, but the style of problem, the type of problem is going to look identical to this, except the numbers are just going to be different. The angles are going to be a little different. All right, let's do one more. So these are the last 6 problems. All right, this is going to be an isosceles trapezoid. Let's move that over just a tad. All right, this is isosceles trapezoid. What does it mean to be isosceles trapezoid? Come on. 2 pair of equal sides? Just 1 pair. Just 1 pair on a trapezoid. And this is parallel. Now, they're going to throw some diagonals in there. Did we talk about that today yet? What's true about the diagonals on an isosceles trapezoid? I think we talked about it when we were going over the homework. They're congruent to each other. Yeah. So, just to make it a little easier for us, I'm going to make them both red. Okay, both diagonals. So when you have a situation like this, see the 2 red things? 2 red line segments? They are equal to each other. All right. Here's what they're going to give you. They're going to give you some stuff. Let's call this A, B, C, D. Let's call this X in the middle. And let's call it V. All right, and here's what they tell you. Find AC. That's what we're trying to find. Find AC. And they're going to give you some stuff. DV. Let's just put it on here. I don't know. Let's just make something up. Let's say that's 5. Is that all right? So DV is 5. And AV is, I don't know. Let's go 8. Is that all right? Okay, so AV is 8. All right, and what are they asking you to find? AC. Well, check it out. AC. I want to find that length, that diagonal right there. Or I could find this diagonal. They're the same, aren't they? Aren't they exactly the same? Yeah, doesn't matter. So where do we start? What do I know? Let's start here. Do I know anything else about that? Yeah, VC is going to be the same exact thing. You see that? That DV and that VC or CV? Excuse me. If that's 5, this is going to be 5 as well. Just knowing that makes it super easy. What is BV? What do you think BV is equal to? From here to here. Yeah, it's the same as from A to V. Everybody see that? So the 2 little parts are equal to each other. The 2 medium parts are equal to each other. And of course, the whole diagonals are equal to each other. What are you trying to find? AC. AC is super easy now. How do you find from A to C? Add them up. That's right. From here to here is 8, and then from here to here is 5. What do you do to get the whole entire thing? Just go 8 plus 5. What's that? 13. And so AC would be 13. And that's how you do that. That's number 20 on the test. Numbers are different. I just made these numbers up off the top of my head right now. They give you different numbers. They're a little bit bigger. They're not crazy big, but they're a little bit bigger. But that's what you would do. So make sure you go over that and look at it. Should be good to go. All right, that's enough of section 6.5. All right, so let's scooch all the way back up to the quizzes. Tell you what we'll do. Do you remember how we did the substitution stuff? Remember that? Okay, we are not going to have any problems where you have to do substitution. So I probably pulled up the wrong quiz because I should have pulled up the other quiz. Because on this one, you had to do substitution. See how that 2y plus 1 and that's x plus 3? You had to set them equal. Then you had to set these equal. So you had to substitute a little bit. You're not going to have to do that on the test. So I went over everything in the other class up through number 8. So I did, yellow doesn't show up very well there, does it? Okay, so I went through number 8 in the last class. All right, just so I don't have to repeat myself, if you want to go back to watch that video, it's a very, very quick rehash of those problems. Now, right here, let's do this. QR. How in the world would you find QR? Well, you would set this one and this one equal to each other. The one that you're looking at right now on this quiz is more difficult than one on the test. The one on the test is easier. All right, you're going to have something kind of like this. Yeah, it looks almost identical, except you're going to have x's here. All right, so you just set them equal, you solve for x. And then you're going to have a y here and a y here. You'd set them equal, solve for y. And then you plug it back in to find out what you need to solve for. Everybody understand that? All right, so it's easier than what you're looking at right now on the test. So you set those equal to each other, solve for x, and then you set these equal to each other, solve for y, and then you can plug it back in and find whatever they ask you to solve for. Okay? All right, so there you go. Let's go to this. I did not cover this stuff in the last class, so hopefully the people in the last class are watching this. I told them to. I kind of doubt they are, but you never know. There might be somebody. So watch this. It says, this is kind of like what we just did with a slight difference. It says, find the value of x to ensure that this is a parallelogram. They don't tell you it's a parallelogram to begin with. But what must be true if it was a parallelogram? Well, these two would be parallel or I should say this, these two would be what? Equal to each other, and these two would be equal to each other. So what do you do to these two? Set them equal and solve for x. Then what do you do here? Set them equal and solve for y. And that's all you had to do for those. Yep. So there's one that looks pretty much just like this. And there's one on the test that looks pretty much like this. No substitution, okay? So you don't have to worry about that. That caused some people some problems. It actually didn't cause as many problems as I thought it might, but there you go. Yeah, let's go to this. So what do you do here? Find each length of a rectangle. Find QS. QS is that whole thing if PR is 12. Well, if PR is 12, what's true about the diagonals of a rectangle? They're congruent. They're equal to each other, okay? Just like in an isosceles trapezoid, all right? The diagonals are congruent. So if they tell you PR, which is from here to here, is 12, what is it from Q to S? It's the same exact thing. It's just 12, okay? This one says QT is 5. Where's QT? Right there. If that's 5, what is PR? Well, if this is 5, then ST is 5, but that's not what they asked for, is it? They asked for PR. Well, PR is equal to QS, just like we said up here. So if QS is 10, what's PR? That's also 10. All right, let's keep going. We might actually finish this. Find the measure of each angle. Angle 1 is what we're trying to find right there. Well, what else do they tell you? Really, the only thing else they tell you is this angle right here is 35. Do you see a relationship without... they're not opposite. What do we call it? Alternate interior angles. That's right. So 1 and 35 are alternate interior angles. So alternate interior angles are equal to each other. So I don't have to do any math at all. What's angle 1? 35 degrees. All right? Everybody good? What about angle 3? What about this one right here? So check this out. If angle 1 is 35 degrees, what's this angle right here going to be? 35, because if you look at this triangle, that's right. So if this is 35, and why is this 35? Because I got two equal sides, right? And the angles opposite a triangle with two equal sides are equal to each other as well. So you add those up, what do you get? 70. How do you find what's left over? Take it away from 180. What's that? 110. So you had to do a little math. You had to add up the 35 and 35 to get 70. Then you had to take that away from 180, and that's what this angle is right there. It's 110. All right, let's do another one. This is a rhombus. What do we know about a rhombus? They actually show it to you, right? They put all the sides equal to each other. So that was nice of them. Well, nice of me because I'm the one that made the test, all right? So they got all four sides equal. We got to find angle EFG. Where is that? That's this angle right there. So what are we going to do? What are we going to do? What does the diagonal do on a rhombus? What does it do to this angle? You remember? It bisects it. Very good. Okay? So on a rhombus, only on a rhombus, does this diagonal bisect that angle. So where do I go from there? Well, this diagonal bisects this angle down here, doesn't it? So if this little one's 60, tell me about this one. 60. And you're probably thinking, well, why, Mr. Hammer, why are you going down here? We're trying to find this angle up here. What's up with that? So, well, they're not all congruent. What's that whole big angle G going to equal? 120. Okay? So, watch. This angle G and this angle F, what's true about them? Are they equal to each other? Is this 120? No, there's no way that's 120. Why is there no way? Just by looking at it. It's less than 90. It's an acute angle. That's right. So there's no way that they're equal to each other. But if this is 120, how do I find this angle right here? That's right. Okay, and that's 60 degrees. So this whole big angle right here, okay, EFG, that's what they ask for, is what? 60 degrees. Got it? Because these are consecutive interior angles, parallel lines, cut by a transversal, they're supplementary. Okay, we've talked about that before. So that whole big angle is 60 degrees. What do they ask for here? Angle 4. Yep. Because if this whole thing is 60, what are these two tiny angles here and here? That's 30 and that's 30. And that means this whole angle is going to be 60. So what are these two angles? They're both 30 and 30. Okay? So angle 4 is 30 degrees. Look what I did every single time with my angles. What did I put? I put a degree symbol, didn't I? Okay? Make sure that you do that. Okay? If you're finding an angle, put degrees. If I'm finding a line segment, look what I did not put on these two. I did not put what? Degrees, because this is not an angle. It's just a line segment, okay? It's how far it is from there to there. That is not an angle. All right? I'm really getting tired of people you wouldn't believe how many times I got to correct that. All right? And I'm giving you credit for it. If you put 12, if you put 10, and you put degrees, I'm giving it to you. A lot of teachers would not. And I probably should not give it to you. All right? But I'm just too nice. I figured if you did the work to get this, you don't believe me? You don't believe I'm too nice? What? I saw that look. You look at each other like, yeah, right, he's too nice, sure. But I am as far as grading compared to other teachers, all right? I really am. Other teachers would mark it wrong. If you put 12 degrees, bam, that's what other teachers would do, all right? I don't do that, but I'm just telling you. Now in my honors class, I told them I would, all right? And I am going to do that in my honors class. If they don't put degrees, I'm marking it wrong. If they put degrees right here when it's supposed to be just a length, I'm marking it wrong. So I am doing that for my honors class, all right? I'm letting up a little bit on you guys, but I shouldn't. Okay, you're smart enough to be able to figure this out and not put degrees when you shouldn't. But anyway, just saying. Oh, I see something that's not on any of these quizzes. Ooh, that's on the test. Here, let me fly down here, way down here. We talked about this, but very briefly. It's not hard at all, but let me just show you. You got copy, 1, 2, 3. I'm going to try to evenly space these. If they're not evenly spaced, just pretend they are, okay? All right, everybody good with that? Do they look evenly spaced? Pretty close. I hope people from the other class are watching this because this, and this are equal. And all right, what if they told you that this little thing right here, from here to here, everybody see that? Now, if these are all parallel, and they are, okay, they tell you in the problem that these are all parallel. If these three things are equal, then these three things are equal. Why did I put 3 there? And then these 3 things are equal. Everybody see that? So if this is 2, what's this one right here? That's 2. What's this one right here? That's 2. What if this was 5? This one right here. What's this one equal to? 5. And what's this one? 5. Everybody see that? What if this was 6? What's this one? Are you magically healed now? Did they call the Did you go to the emergency room? All right. Everybody see that? Super easy. So if they tell you one of these things, then these two are going to be equal. If they tell you one of these two are going to be equal. If they tell you one of these two are going to be equal. That's all there is to that problem right there. Okay, that's the only, it looks like it's the only problem that has not been on a quiz. All right. Everybody good? Tomorrow you're taking the test? Well, if you're not taking the PSAT. Is anybody not taking the PSAT? All right, so if there's only like 1 or 2 people in here, we probably will not take it. We'll probably just wait till you come back and take it, all right? So maybe you're going to take it Wednesday. That means no video day on Thursday.